Hello everyone, my name is Anggit Raksajati. In this video, I'm going to present you an overview of energy equation for compressor in fluid mechanics and particle course. So compressor is used to increase gas pressure from point 1 to point 2. The work of compressor leads to change of fluid temperature and density. Specifically, the temperature will increase and the density will decrease, or the volume will decrease. Why? Because compressor is used to compress a gas which is a compressible fluid, and that's different compared to a pump where it compress liquid, the incompressible fluid. So which one is more effective or efficient? Actually, it is much more easier to compress pump or liquid using a pump, and it is more energy efficient. Why? For a pump, we're working with liquid in compressible fluid, so almost all of the work supplied to the pump will be used to increase the pressure without any partial use for increasing of temperature or even the density. Meanwhile, in a compressor, because of the characteristic of the gas itself, a compressible fluid, some of the work is used partially to increase the temperature and to reduce a gas volume. Hence, only some of the work can be used to increase the pressure. So let's say you want to compress from 1 bar to 10 bar between gas and water at the same mole flow rate or same mass rate. It is always 100% will be more cost and energy effective to compress a water or a liquid because of this characteristic. Assuming the change of kinetic energy is much less than the change of the compression energy, the energy equation for compressor can be expressed as integral VdP plus EF, or the friction, equal to the work of the compressor. For the ideal compression, where the friction is neglected, so the work is equal to V times integral differential of pressure. But again, you have to remember that the volume and the density will change along the way during the compression process. That's why it becomes more complex. But luckily, we already learned about that in the thermodynamics course, where we can calculate the compressor work or the energy requirement based on two principles. You can calculate based on adiabatic, where the P1, V1 power of gamma is equal to P1 V2 power of gamma, where gamma is Cp per Cv, and the compression work or the compression energy based in joule per kilogram can be calculated using this equation as a function of gamma, P1, V1, and then the compressor ratio, where the increase of the temperature can be calculated using this equation. P2 per P1 will be equal to T2 per T1 by power of gamma per gamma minus 1. So that's for adiabatic. And remember, this is for reversible ideal process. We haven't taken into account the efficiency. And then for the polytropic compressor, the assumption is constant P multiplied by V power by K, where K is the polytropic coefficient. And the equation to calculate the energy required is quite similar. You just have to replace every gamma in the adiabatic equation with K, the polytropic coefficient. Every time you find a gamma, replace it with K. That's for a polytropic. In essence, where the K is equal to gamma or Cp per Cv, the compressor work for adiabatic and the polytropic will be identical. And then when you want to express it as a power, for example, in watt or joule per second, so you just have to multiply the previous equation with the mass rate, where you initially have joule per kilogram, now you multiply by kilogram per second, now you have joule per second or watt. And then that's still ideal or reversible power. When we want to calculate the actual power, we have to take into account the efficiency, and then we can have the polytropic efficiency. For example, that's the efficiency. In that case, the power required, you just have to divide the ideal or the reversible power divided by the efficiency. Now you can gather the actual power required by that compressor in watt or joule per second, because you already multiplied the mass rate. And in terms of the mechanical efficiency, due to mechanical rotation work of the compressor, let's say it is expressed that the efficiency of the compressor is 75%. That means out of 100% of the energy supplied by the electricity, only 75% of them is used to increase the pressure. That means when you want to calculate the actual power required, again, you just have to divide the previous fraction with the efficiency of the mechanical efficiency.